Hello friends, here in this video we will see the example based on the spiral spring. Okay, now we can see the data of it first. A spiral spring of 2 meter length is having the rectangular cross section of 6 mm width and 0.25 mm thickness. If the spring is made of alloy steel having allowable bending stress of 500 Newton per mm square and the modulus of elasticity of 207 gigapascal. Okay. Now determine the torque that can be applied to the spring. Second one is the number of turn wound under the applied torque, and the third one is the strain energy stored in the spring. Okay, now start the example. First, given data. First is given data. Okay, data is the spring length 2 meter. Okay, so L is equal to 2 meter is equal to 2 into 10 raised to 3 mm, right? Is having rectangular cross section, so that's why 6 mm width. Okay, B is equal to 6 mm and thickness is equal to 0.25 mm. Okay, 6 and 0.25 mm. If the spring is made of alloy steel having the allowable bending stress, okay, allowable bending stress is equal to 500 Newton per mm square. Okay, and the modulus of elasticity, that means E is equal to 207 gigapascal is equal to 207 into 10 raised to 3 Newton per mm square. Okay, now we start the example. First we have to find out the torque that can be applied to the spring. Okay, so first torque that can be applied on spring. Okay, so the equation is we already seen in the theory. Sigma B is equal to 12T upon BT square. Okay, it is the simple equation. So we have the value of sigma B, value of B and T, so we get T. Okay, so that's why sigma B is equal to 500 is equal to 12 T upon B, means B is equal to 6 into 0.25 square. Okay, so on this equation we find T is equal to 15.625 Newton into mm. Okay, so first one is completed, the torque that can be applied to the spring, right? Newton into mm. Okay, second, the number of turns wound. Okay, second, number of turns wound or winding under the applied torque. Okay, or spring under the torque. Okay, so the general equation of the turns of the wound of the spring is one turn of winding of the spring is equal to 2 into pi radians. Okay, okay, generally we can see the theta is equal to n into 2 pi. Okay, so we have to find n, so n is equal to theta by 2 pi. Okay, but we don't have theta, we don't have the value of theta, so first we have to find theta. Okay, theta means angular deflection. Okay, angular deflection, right? So the angular deflection equation is directly 12 into T into L. Okay, we put the direct equation into upon E into B into T cube. Okay, we have all the values T, L, E, B, T cube. Okay, 12 into T, the value of T is equal to 15.62, and L is equal to 2 into 10 raised to 3 means 2000, divide by E, the value of E 207 into 10 raised to 3. B is equal to 6 and T is equal to 0.25 cube. Okay, now after calculating, the value of theta is equal to 19.32 radians. Okay, the value of theta is equal to 19.32 radians. Okay, it is the angular deflection, right? Then after we have to find the number of turns found under the applied torque. Okay, so we have to one turn of winding of the spring is 2 pi radians. Okay, now how equation is come, the number of turns of the winding of spiral spring is n is equal to theta by 2 pi. How? On this equation, right? So we have the value of theta is equal to 19.32 and 2 into pi, so that the number of turns n is equal to 3.07 ton. Okay, it is the solution number 2, number of turns. Okay, now final, the strain energy. Okay, third one is the strain energy store. Okay, strain energy store, okay, in the spiral spring. Okay, so the equation is U is equal to 1/2 T into theta. Okay, so we have the value of T and theta. T is equal to 15.62 and theta is equal to 19.32. So after calculating, the value of strain energy is 0.15 Newton into meter. Okay, and it is also 0.15 joule. Okay, so it is the solution of strain energy store in the spiral spring. Okay, so it is the answer. Thank you.